Data security is a challenge in all of our environments, and today we're going to talk about two geographically dispersed sites and a way that we can secure data and increase performance to be able to provide additional services that are needed at these sites as well. So let's go ahead and jump in and configure Site A. Now that we've established the sites and them running, we're going to have to add some services to these sites. And some of these sites are going to need a variety of services. So by privatizing this WAN connection, we're able to offer customers many services that will actually work properly and be a lot easier for them to implement. So let's start a couple of those here with LTE service. This is just like data LTE that you receive on your phone today, or a mobile device. We can offer that as part of their service. Imagine, for example, the Veterans Administration using LTE to serve patients just a little bit better. And of course, we can extend, which tends to be a real challenge in many environments, these multiple devices within their environment. Of course, remember, we use the backbone of Aruba to assist us with these multiple devices and management and security of those devices. And then we quickly move in to the ability to truly do VDI and HDI within the environment. Now, this is a challenge for a lot of environments for bandwidth, and especially when you start talking about implementing VDI across a wide area network. And so here, when we privatize a WAN, when we put two geographical sites as shown here together, this becomes a real possibility for sites and a huge value add for many customers that are in the industry today. And then, of course, we have live motion of the virtual machines. Now, remember, if you haven't viewed any of the SDN videos, you should view those. But essentially, one of the restrictions to migrating a virtual machine, now I use the word migrate and I didn't mean to, moving a virtual machine from site A, represented there in the left, to site B, represented down on the bottom right, one of the challenges is the IP schema. Now, in a privatized WAN, here we have the same IP schema stretching across both sites without having to implement SDN like Nuage, for example, or Nicira. Here it's natural within the environment. And so live motion, meaning that that virtual machine can just be moved to another resource at another site, and all of the resources associated with it move along with it, is very, very powerful. So live motion, no downtime at all, no restoring, no migration. This is truly live motion or virtual machine. So that's pretty powerful and a huge request by many customers. And of course, you cannot forget analytics and the ability to share information. And the last, certainly but not least, of one of these great benefits of a privatized WAN is the ability to share secure data. Secure data from the sense that this is private within my facility. Nobody else. I'm monitoring. Remember, we're reducing the vector points of attack, and we're going to talk about that here coming up. Internal communication within a local area network, example would be Site A for a great example, right? Most of their communication is done internally and routed internal. They have a router that sits there and communicates to the outside world, do what we call the wide area network. Now, this is no different than the implementation here that we're talking about privatizing the wide area network and making it kind of like a local area network, but include geographically dispersed sites. And we can do that. Technology is matured to a point where we can do that today. And that enables all kinds of security and solutions. So, for example, we have a secure environment where, let's say that we are communicating internally within our own environment, right, between site and site. We're doing that 80% of the time. We really only talk between site A and site B. Well, in a non-privatized WAN, what happens is the communication traffic goes out to the internet where there is a greater risk of cybercrime, right? Because there are more attack vectors available. We communicate over the public internet, and then we come back down into site B through that public internet. Now, if 80% of our traffic is really between site A and site B, only 20% needs to go out to the public internet where it's a little dangerous out there with the cyber criminals. Why are we doing that? Well, we're doing it because private WANs really have not come up to speed in the last years. In the last several years, they have really taken on some speed and are really doing some great things. And so, privatizing these large infrastructures, even small infrastructures, reducing the number of places where we could potentially get attacked is going to provide us a more simplified and secure environment. It's just as simple as that.